For the reaction above carried out in solution of 30 degrees C, the following kinetic data were obtained. Calculate the value of the specific rate constant K at 30 degrees C. So the first thing I have to do is write a rate law. I don't know the rate law for this yet. So I'm going to do that by, first I need to look at, let's see, we'll do reactant A first. And to do that, I'm going to look at this experiment, experiment 2, and experiment 4. And the reason I'm going to do that is because in that case, the concentration of reactant B is held constant. So I can just do a simple proportion to determine the reaction order with respect to A. So I'm going to set a proportion of the rate, so 2 over 0.5, that's my rate, is equal to the concentration 0.240 over 0.120. Okay, so what did I do to my concentration? On the right hand side here, I doubled my concentration. And what happened to my rate? On the left side here, it quadrupled. So the order then must be, N with respect to A must be 2. So second order with respect to A. Now, what about reactant B? So for reactant B, I'm going to choose experiments 1 and 2, because again, in this case, reactant A is being held constant, so I can set up a simple proportion to find the reaction order with respect to reactant B. So what am I doing to my concentration here? So 0.480, my concentration in experiment 1, 0.120, my concentration in experiment 2, is equal to the rate, 8 over 2. So here I get 4 on the left and 4 on the right. So that means I quadruple my concentration. The rate also quadruples. We call that first order, or 4 to the first power. So first order with respect to B. Okay, so given that, I'm going to clean up some space here and write a rate law. Second order with respect to A, first order with respect to B. So the rate is K, A to the second, B to the first. And then I just have to pick data from any experiment. I'll choose experiment 1 since it's the first one there, to find the rate. So, to find the value of K. So the rate is 8. Now my units here, moles per liter per hour, okay, divided by the concentration of A, which is 0.240 moles per liter squared, times the concentration of B, 0.480 moles per liter. Okay, in a calculator here, I got 289. So I've already gotten myself to answer choice C, but let's make sure that I can get these units. So I have a circle in a different color here. On the top I have moles per liter. On the bottom I have moles per liter squared times moles per liter, which is moles per liter cubed. Okay, so moles per liter on the top divided by moles per liter cubed on the bottom leaves me with moles per liter squared on the bottom, which in your answers is written as liters squared over moles to the -2, or flip it and it's moles per liter squared. And then of course the hours is on the bottom here, so hours to the -1, which is answer choice C.